Okay, so hello grade 8. Today we're going to continue our unit about chemistry, and we're talking specifically about different things that we can observe in matter, and in particular the difference between a physical change versus a chemical change. So, what is matter? So matter is anything that has weight or mass and takes up space, known as volume. We've talked a lot about this, so pretty much this encompasses everything you interact with on your day-to-day life, all the way from solids, so rocks, plants, to liquids like water, soups, etc., and gases like smoke, clouds, steam, etc. Just a reminder that you are also in fact matter because you do take up space and you do have a mass. So today what we're going to talk about is the difference between a physical change and a chemical change in matter. So when I'm doing an experiment with matter, so you can think about it if I had a piece of paper, which is matter. It's solid. A physical change would be me ripping up that paper. So I haven't changed the physical structure of the matter. The matter is still paper. All I've done is I've gone and ripped it up into different size pieces. So it's still paper. So that's a physical change, is when we are taking that existing matter and we're either changing its shape or maybe putting it through a change of state, which I can't do with paper, but if I, for example, had a piece of chocolate, if I melted that chocolate, that would be a physical change. So I'm putting it through a change of state. So the composition of the matter hasn't changed. I haven't made a new substance. There's been no chemical reaction. A chemical change is where that piece of matter is no longer the same substance. So I had something that I put in at the beginning of my chemical reaction, and the thing that I get out at the other end isn't the same type of matter. There's been a change in structure there, and we'll talk a little bit more about that. So when I'm looking at matter, I can observe two different things about that piece of matter. I can observe its physical properties. So these are characteristics of matter that we can observe or measure without changing the chemical structure of that matter. So those, you could think of those as your first kind of observations. You're not adding any fire, not mixing it with any chemicals, etc. All you're doing is observing it without meddling with its chemical identity. So if I boiled a pot of water, I could check the boiling point. I haven't changed the chemical structure of the matter. I could observe its color, measure its temperature. I could see how shiny it was, make observations there, its volume, its mass, size, and density, etc. So to look at any of these properties, I don't have to change that chemical structure of the matter that I'm looking at. So when we're describing matter, we can look for physical changes. So a physical change is a change that alters the substance without changing its chemical identity or composition. So the matter has not changed. This, for example, could look like crumpling up a piece of aluminum foil. So I still have aluminum. I haven't changed the chemical makeup of aluminum. I'm just presenting it in a different way. So that's a physical change. Folding a piece of paper into a bird. Creating a mixture. So for example, if I combine salad leaves with tomatoes, onions, etc., I chop them all up and I combine them together. But if I really, really wanted to, I can still pull out those individual elements and I haven't altered the matter at all. So I haven't made the salad leaves a new thing by combining them in a salad bowl. I can still separate that out. So it's important to think of things like mixtures, which we'll talk a little bit about what a mixture is later. When we create a mixture, we're not necessarily going through a chemical change. It's typically a physical change because typically we can reverse that process. So that's the trick. So when we're talking about physical changes, we're talking about processes that can be reversed or that don't change the chemical identity of whatever it is you're doing something different with. So onion again, If I have a whole onion and I decide to chop it up into different pieces, I haven't changed the chemical identity or structure of the onion. It is still the same. I've just changed its kind of physical presentation. So it's just a physical change. Another example of physical changes are changes of state. So we talked about changes of state last week, talking about evaporation, freezing, melting, etc. Anything that is a change of state, no matter if it's water, chocolate, gold, etc., or ice cream, that's just a physical change. So I haven't altered the structure of the matter. There's no chemical difference there. I'm still looking at water, so H2O, or I'm still looking at ice cream, okay? So that's, again, a kind of example of that. So I can reverse this process if I wanted to. That's kind of the key here. So if I wanted ice back, I could freeze the puddle of water and I could have ice again, or ice cream. Or if I put a lid on this pot, I would gather all the steam, and then when it cooled down, the water would condense, drip off the top of the lid, and it would be back in the pot as water. Chemical properties are a little bit more interesting. So physical properties, things we can just observe about the matter, changes of state, maybe a physical kind of ripping up or like cutting up of the matter, but it's not changing the chemical properties. Chemical properties, on the other hand, are characteristics of matters that we can only observe in a chemical reaction. So we can't see that iron is rusting unless there's that chemical reaction that's occurring. Sometimes you see this very, very obviously. Sometimes it's very, very subtle and it takes a long amount of time. So chemical properties describe the ability of matter to react. So these are 3 types of chemical properties. There's more than this, but these are 3 ones we're going to kind of highlight. So reactivity. So we can see chemical properties when we combine one type of matter with another type of matter. So in this case, zinc reacts with acid. Flammability or combustibility. So how easily does this thing catch on fire is a chemical property we can observe. And then oxidation is another one that's really important. So when a piece of matter interacts with oxygen, what kind of chemical reactions occur? So in this case, iron, when it's spent a lot of time out in the open air interacting with oxygen, it'll actually start to rust. So when we're describing chemical changes, these are kind of some good giveaways that a chemical change has occurred. So we might see a change in texture, change of energy in the form of heat. So if a powder is mixed with a liquid, and then when you put them in the bag, there are 2 cool temperatures, but when you put them in the bag, they produce heat. That would be a good example of a chemical change. So you've seen something there. Evidence of a new substance forming. So this clear liquid is being poured into this clear liquid, but it's formed this kind of crystal-like yellow structure. So that's another good way to tell if there's a chemical change happening. A change in color. So when you bleach your hair, that's a chemical reaction that's occurring with the bleach. So that's a good way to see that there's a chemical change. Release of a gas. So anything from like bubbling to smoke or steam coming out of it. That's a good sign that there's a chemical change occurring. Or new smells. So something like smoke when you're cooking something. That's another chemical change. So you can have that kind of scent that's coming off of it. So we're just going to go through them one by one. So one type of chemical change is reactivity with other chemicals. So some substances react very vigorously with acids, others do not. So for example, if you mix baking soda with vinegar, it produces a gas. Fireworks are an example of a reactive material. So when it is combined with something else, it causes a reaction. Mentos and Coke. Nitrogen triiodide and ammonium can cause a just kind of explosion when you chop them. It's quite cool. Another type of one is reactivity with oxygen. So you probably have seen this in your own house. So when substances and some foods react with oxygen when they're exposed to air. So something like an avocado, if you leave half of it out uncovered, it's going to start to brown. So that's a reaction happening there, chemical reaction. An apple browning is another example, just in case you're not a big avocado eater. Again, we talked about rust. So rust is occurring because of oxidation. Combustibility. So this is another good sign that a chemical change is happening. So some material will catch fire and burn in the air. So burning wood. So when you have a fire, we talked about this at the beginning of the year, you need to have an ignition source, and you need to have material to burn, and you need to have oxygen. So those are your three kind of components there. So when we've got combustibility going on, we're talking about a chemical reaction there. So this piece of wood is not going to be the same chemical structure on the other end of this experiment. It's going to be ashes. So I've produced a new product here. So this is a sign that this is happening. I've got smoke that's happening. I've got heat that's occurring. So this is a chemical reaction. Again, when you put a match to a box and you scratch it, this is another chemical reaction that's occurring. So this is causing friction against another surface. Chemicals are interacting that causes the flame. So that's, again, another type of chemical change. If you have a gas stove, gas is igniting with an ignition source. That's, again, a sign of a chemical change. So you've got a certain smell. It's giving off heat. These are all really good signs. We'll go back for a second just to kind of reiterate this. Things like color changes, that's a good sign there's a chemical change. Again, texture is happening here. New substances being produced. Gases was something we talked about. Another kind of, not physical change. Let's just change that. Forgot to change that on my PowerPoint. Another kind of chemical change that can occur is decomposition. So some materials will decompose or break down. This is all happening because of chemical reactions. So dead leaves, old fruit will start to break down. So again, we've got changes in texture. We've got changes in color. So the leaves at the end of the summer, they go from green to red to brown when they start to decompose. So this is another sign. So decomposition or rotting is a sign of a chemical reaction occurring. Another type of chemical reaction or chemical change that we can look at is lack of reactivity. So just because a substance doesn't necessarily have a big reaction, if it's not reacting with something, this is actually a chemical property as well, which is known as lack of reactivity. So some substances don't react with one another. Substances are known to be inert. So for example, helium is an inert gas, so it doesn't react with other gases. So when we're looking at a chemical change is also known as a chemical reaction. So in a chemical reaction, we have reactants and products. So I'll just give you kind of an example. So reactants are things that we put into an experiment, and then at the end of the experiment, we're going to have something new that's created from this experiment. So for example, in this bottle, I've combined baking soda and vinegar, let's say. So that would be my two reactants, is my baking soda and my vinegar. My product, on the other hand, is going to be the gas. So if you've done this experiment before, you'll notice that it starts bubbling vigorously. That's because it's producing a gas. So I've shown that by the balloon that's here. So that would be my product, is I've created a gas. So I've combined two things. On the other end, I don't have the same substance. It's a new chemical makeup. So during chemical changes, new substances are going to be produced. So steel forms rust. This is a new substance. This isn't steel anymore. It's something else. Food rotting. Rotten food doesn't have the same chemical makeup as food that hasn't rotted yet. Gasoline producing smoke. Gas produced by baking soda and vinegar would be another example. So matter can be described based on physical and chemical changes. So we've got some examples here. Your teapot is an example. Oops, I didn't know that was going to be the first one. Your teapot is an example of a physical change versus toast is an example of a chemical change. So I've got a change in color. The toast is going to brown slightly. The toast is going to get warm. The toast is going to let off an aroma. So there's a smell that I can smell in my kitchen. That's a good sign that the chemical change is happening. Physical change, boiling water. If I really wanted to collect all this steam, I could turn it back into water. So that's just a physical change. So the physical structure or makeup of the chemical or matter has not changed. Versus this toast is a totally different substance. Toast is a totally different substance than bread. Cooking bacon would be a chemical and physical change. So the chemical part of this is that the bacon is not the same kind of structure as it was before, but the physical change is all that bacon grease that's come off of the bacon. If I wanted to reheat grease up, you'll know that grease kind of liquefies again. That's like physical change that's happened with that bacon. So kind of quick explanation of what's going on here is when we have chemical changes, what's happening is we've got elements kind of combining together. So everything around you in the world is made up of a combination of different elements. So for example, on this we've got oxygen, things like sulfur, calcium, sodium. So when you think about something like salt, that's sitting on maybe your kitchen counter, salt is a combination of sodium and calcium. So what happens when we have a chemical change is these things that were originally paired together are maybe going to get swapped out with something else or be separated or moved around. So we'll talk a little bit about that. So when we talk about elements, we're talking about this lovely periodic table. So the periodic table was created to organize all of these different elements that we can find in nature. So scientists went around, kind of figured out what everything was created from or made from, and organized it into this periodic table. So for example, where would we find these elements in nature? Some of them will be found in mines. So this is a picture of a copper mine that's got a really cool patina going on it. So it's a chemical reaction with the copper and the air. Silver is found in mines. Iron is found in mines. Salts found in mines. So all of these elements that we kind of look at really abstractly on the periodic table are actually things that we can find and gather from the earth. So these are all of the elements that we can find on the earth. So everything that you interact with on a day-to-day basis is some combination of these elements. So matter can be classified based on how it responds to physical and chemical changes. So matter is either a pure substance or a mixture. So most of the matter in the world is a mixture. So a mixture is going to be a combination of different elements. A good example of a mixture could be like a salad. So in a salad, I have my lettuce, I have my tomatoes, maybe I have some cheese, maybe some croutons. That's a mixture. So I've got lots of different elements, different things that have been combined. A pure substance, on the other hand, is what we're talking about when we're talking about elements. So copper can be found naturally in the environment. It's not combined with anything else. I couldn't break it down to make it into something new, it's always going to have copper in it. So that's an element, which falls under the title of pure substance. So copper, iron, silver, anything that's on that periodic table is known as an element. Compounds, on the other hand, are combinations of elements. So remember I mentioned salt. Salt is a combination of sodium and chloride. So that's what table salt is made out of, sodium chloride. So that would be known as a compound because it's a combination of two elements. So again, in a pure substance, all the particles look alike. So remember we were talking about particles before. So we have everything is made up of particles, right? So every type of substance. So something like if I had a copper penny, it's not just made out of one particle of copper, it's made out of a ton of really tiny particles of copper. So in a pure substance, all of the particles are going to look alike. So if we're thinking about something like a copper penny that's only got copper in it, all of those are going to look the same. It's pure. A compound, in other words, can be broken down further into elements by chemical means. So if we have a compound, I'm talking about two elements in combination with each other. So for example, water is a combination of hydrogen and oxygen. So if I wanted to separate the hydrogen and oxygen out, I could do that, but I'd have to do it through a chemical process. I couldn't just take the cup of water and separate it by hand. That doesn't work. But I can break it down by a chemical process. So that's kind of the trick about compounds, is that I can break that down through a chemical process. Something like carbon dioxide that's in the atmosphere that you're breathing in. Remember we talked about how plants exhale or inhale carbon dioxide and you exhale carbon dioxide? That is a compound. So that's a combination of carbon and oxygen. So those, if I wanted to separate the carbon out from the oxygen, I could do that, but I'd have to do that through a chemical process. Glucose, so that was that sugar that we talked about when we had our biology unit. Glucose is a combination of carbon, hydrogen, and oxygen. And again, if I wanted to, I could break it down. So this is kind of an idea, is I've got a particle here. So this is H2O, because I've got my hydrogen atom here. Got my hydrogen atom here, and I've got my two oxygen atoms here. Okay, so that's my thing. So I've got two particles that are connected to one another. So if I wanted to, I could break apart those particles, but they're very tiny, and I can't do it just by hand. I'd have to do it through a chemical reaction. Elements, on the other hand, cannot be broken down further. These are the smallest kind of part that we can look at them. So example, solid gold, solid silver. I can't take solid gold, put it through a chemical reaction, and get out a new substance. It's still gold, okay? So all of the particles of gold look the same. They're not combined. They're not a mixture of things. That's what's going on. So if I wanted to melt down my gold, I'd still have gold. So it doesn't matter what kind of chemical reaction I put it through. So solid silver, again, they're all combined. Mixtures, on the other hand, are a little bit more easy to separate out by hand. So a mixture is two or more different types of particles. So for example, here I've got salt water. So this water has salt in it. If I wanted to remove the salt from the water, I could physically separate them out by the process of evaporation. So that's not a chemical reaction, that's a physical change, right? Evaporation. So if I evaporated that water, so I heated it up and the steam started coming off, I'd be left with a pan that had a bunch of white stuff at the bottom of it. So that would be my salt. If I mixed a bunch of pieces of iron into sand, I could take it out with a magnet. So iron and sand mixture, iron can be separated from sand by using a magnet. So before I move on, I'm just going to give you a quick little example because it is a little bit of a tricky concept that I put up here specifically. So when we're talking about mixtures, we're talking about things that we could physically separate out. So for example, salad is a mixture. I could take all my tomatoes, pull them out, and I could put them into a separate bowl. I could take all my pieces of lettuce, put them out, put them into a separate bowl. If I wanted to get the sugar out of my coffee, I could evaporate my coffee, and at the bottom of the cup would be the sugar. Even if I dissolved it, it would still not come with that coffee. So there's a physical process I can do to separate that out. Again, if I've got a physical change going on, I'm not making any dramatic change to the physical structure. I could collect the steam and put it back in the pot and turn it into water. I could refreeze this ice cream and it would still be ice cream. So I'm not changing the chemical structure identity here. Good ways to tell if there's been a chemical change is really, really important. So we'll just kind of go over this last slide. So is it a mixture or a pure substance? So this one here is a mixture. So we could think these as like maybe strawberries, some walnuts. I could pull these guys out. They're a combination of different things. B, this is a pure substance and it is an element. So there's no compounds. This is individual particles. This one over here, I've got a combination of two different types of compounds. Oops. This would be known as a mixture. So something like sodium, maybe I put salt on top of my fries. So there's two different things going on there. I could physically separate them out if I wanted to. D, pure substance. So pure substance because I've got all of the same type of particle or compound here actually rather. And it's a compound because it's not individual things like this guy, it's combined things. This one over here, we've got two different types of compounds that are mixed together, so that is a mixture as well. So kind of the trick here is if you've got the same thing, this is what you're looking for first. You're looking for the same thing. If you have the same thing, it's either going to be an element or a compound. If you've got different types of things, so blue, yellow, pink, that's going to be a mixture. So I've got two different types of things going on here. Always, always, always a mixture. So two different types of things. Two different types of things. If I have the same thing over and over again, if it's individual, that's an element. So that's something we can't break apart. If it's the same thing repeated, but they're attached together, that's a compound. So we're talking about something like water. So I've got my two hydrogen atoms and I've got my oxygen atom. Okay? So just kind of a recap. I'll give you a moment to kind of think about this and then I'll go over the answer quickly. So which one is in a mixture, a pure substance? And if it's a pure substance, is an element or a compound? Okay, so the first one is a pure substance. Is it an element or is it a compound? So it is a compound because we've got these two combinations of particles. It's not the same thing with only one particle. We've got two particles that are attached to one another. So that's a compound. What about this one? So again, yes, it's a pure substance. And there's two types of particles that are attached to one another. In fact, there's four, so that is again a compound. Here, I've got two compounds, but I've got two different compounds that are combined together. That would be known as a mixture. So for example, maybe this is one type of compound and this could be another type of compound. So if I had, for example, this isn't what this is, but if I was talking about air in the atmosphere. So in the atmosphere, we've got lots of different things. Air is a mixture. So we have oxygen in the air. We'd have a little bit of carbon dioxide in the air. This could be the mixture that we're talking about. So this could be my oxygen, or hydrogen and oxygen. So a little bit of water, so H2O, and maybe a carbon dioxide. So mixture. And then our last one again is a mixture.